All right. So where we left off on Friday was a projector that wasn't working and us talking about this problem. Now we've got a projector working, so let's continue where we left off. So this is from section 5.3 in your textbook. I've just gone ahead and entered this data from the table. And you'll remember from Friday that what we said we were going to do is we were going to declare a new variable that we called m that represents this minimum of all the possible outcomes that could occur. So we are going to try to figure out what the best allocation strategy is given these different investment possibilities. And so what we're going to do is we're going to compute for our potential allocation how much we would make in years 1, 2, 3, 4, and 5, and figure out what the worst case scenario is, and we'd want to make sure that this minimum value here is greater than or equal to all of the years, right? If it's greater than or equal to, or I should say it's less than or equal to all these years, then and then we try to push up that minimum, we're going to get the best allocation strategy possible. So let's look at how that works. So what we're going to do is we're going to have our minimum here, which is going to be some value. Like let's just say we want it for visual purposes, we're hoping that it's at least a 4% return or something like that. We'll see how that changes. Let's look at these constraints. So the year 1 is going to be, we're going to have some allocation. What we're going to do is our allocation is going to be our sum product of how much we make in year 1 times how much we allocate percentage-wise for each one of those values. Does that make sense? Right? If we've allocated 50% of our stocks towards our foreign stocks, we're going to get 50% of a return from this 10.06. But if we have only 10% of this intermediate bond, we're going to get 10% of our return from this 17.6. So we multiply what percentage of our money we spend against each stock, and we add those all together. So this is exactly our sum product. Now what we want to say is that the year 1 return have to be larger than this minimum. Okay, but again, we are always wanting to make sure that our right-hand side is a constant. So how do we transform this equation to get rid of this variable here on the right-hand side?
Subtract.
Yeah, we're going to subtract both sides by m. So I'll just do that here. Like that. Okay, I'll write it into my spreadsheet a little bit differently. I'll subtract off that minimum, which is B9 in this case right here. So we have how much we make in year 1, subtract from this minimum right here. And that's our year 1 value. Now, right now it says we're losing 4% because we don't have anything allocated. But if we make a hypothetical allocation, how many? There's 1, 2, 3, 4, 5, 6. So let's do 20%, 20%, 20%, 20%, 10%, and 10%. These all need to be percentages. So let's make those percentages. There we go. If that were the allocation that we made 20% of these first 4 and 10% of these last 2, we would get a return of 20.29% on year 1. All right. Well, actually, we get 24.294, right? So let's repeat that for years 2. Let me make sure that these are not confusing. Return. Year 3 returns, year 4 returns, and year 5 returns. So how are we going to compute then what we are going to get as a return from year 2? What's our return going to be in year 2? Right, so we'll take our year 2 returns and our allocations. It doesn't matter which order you put them in. So Josh said it the other way. I entered them left to right. And again, we're going to subtract off that minimum value right there. Okay, and year 3 is going to be the same way. Right, we're going to take our year 3 allocation, our returns, multiply it by our allocations, and subtract off that minimum. Year 4. And year 5. So we can see this is maybe not a great allocation because of how poor of a year 5 was, right? And we happen to have a lot of these 2 securities that we bought. And so this turns out to have a pretty bad worst case scenario, minus 7.8%. We lose 7.8% of our money. Maybe if we had done something more like only 5% here, and allocate that more sparingly. Let's make this 30%. Hold on. This might be helpful. Okay, let's make this 30% as well. There we go. Now, our year 1 returns are positive of 3% rather than a loss of 7.8%. So we can see that this allocation would be a better strategy for our conservative investor who is worried about how much money they might lose, right? We're trying to minimize our trying to maximize, our worst case behavior. So we're going to represent that worst case with this minimum value, and we're going to see how high we can bump it up and still find some return that when we subtract off this minimum, we will still get a non-negative result. If we ever bump it up too high and we get a negative result, we know there is some case that we can't allocate properly. So let's go ahead and make sure that we have our open solver working. Turning it off and on. Silly strategy here. And I'm good to go. All right, so let's enter this model into our system. What is our objective cell here? Which one are we trying to affect? I thought I heard a murmur, but I couldn't. B9? This minimum here, right? And are we trying to minimize or maximize that value? We want to maximize it, right? We want to get the highest return we possibly can. Okay, what are our variable cells? Where are the variable cells? What are the ones that it should be changing?
The allocation.
The allocation. So let me just go over here. That's not all, though. What else needs to be a variable? It needs to be able to change this minimum, right? Right? All 7 of these values are variables. It can change any of these because this minimum isn't computed. It isn't a percentage times a return. It's just a straight up variable that it can do. And what we want to encourage it to do is get higher and higher and higher. And the things that are going to keep it from getting higher are these yearly returns given whatever allocation strategy it uses there. All right? So constraints. Okay, what are the constraints here? What are the constraints? The returns? What about the returns? What should be true about those returns? Greater than or equal to 0. That's right. So since I have a hard-coded value, I can actually enter a 0 in there. Just to show you what that looks like for a second. See, it shows you that right there. We're not done, though. What's missing?
The allocations have to be equal. The sum of the allocations has to be
100%, right? So this value right here has to be equal to, let's see if that works. Very good, right? Because we have to allocate everything. All right? So does everyone see what we've done here? We can change these allocations, we can change this minimum, and we're trying to maximize it, and we're restricted by having these returns minus this minimum be positive, and we have to allocate all of our resources towards something. Yes?
What's the actual value of the objective function?
Yep.
I don't have it.
There's nothing in there.
It's just,
It's because it's a variable.
right, but what variable? I think I'm just going to ask.
It is our m. Okay?
So you just put it as m?
So, well, you don't have to. This cell, as far as OpenSolver is concerned, is a variable.
Okay.
Right? And so it doesn't have to have a name, right? It doesn't have a name for these, and it can change these values, right?
Okay.
So it just knows that it's allowed to change this value. So it's going to try to pump it up as high as it can, but let's say it put it something crazy, like let's get a return of 1,000%, right? That's going to violate these, right? Because we've subtracted off in every one of these equations, right? We've subtracted off B9, which is this cell right here, right? And these all have to be positive. So if this was 1,000, it would violate all these constraints because there's no way any of these can make 1,000 because none of these values are 1,000. Okay? The highest we could make, if we were really crazy, is 56.68% if we got lucky and we had year 4 returns and had 100% invested in this security. Right? So this represents that m in our equation right here. So let's go ahead and solve it. All right. So notice these values right here. They look weird, but you guys remember what that notation means? Let's do that year 13 returns. 1.4 E minus 0.7. What does that stand for? It's 1.4 times 10 to the negative 7. Which, remember, 10 to the negative 7th is 1 over 10 to the 7th. Or 1.4 divided by 10 million. Right? So for all intents and purposes, that's a 0. Okay? So this is not our year, we're not getting 0 returns from here, right? Because remember, we've subtracted off this minimum. This is, if in year 3, we're getting exactly this return. In year 4, we're getting this return. In year 5, we're getting this return. In other words, if we were correct and we said that these are representative years for our investments, those 3 years, years 3, 4, and 5, we would get that 6.44% return. If we got lucky and year 1 happened, instead of years 3, 4, and 5, we would get this 15.32 on top of this already 6.44 minimum that we had. So we would get a 21, almost 22% return in that year. So we would hope for a year 1 return. That's what we would desire. But we are safeguarded. We get at least that 6.44% return in any given year because of this setup. All right. So if we look at our sensitivity analysis, we can see those 3 years are binding. Right? Years 3, years 4, years 5 are binding. Year 1 and year 2 aren't. Of course, the minimum allocation, 100%, is also binding as well. And we can see things like what the shadow prices are. If we increase those returns, it's going to reduce our objective, right? Because they're binding. All right. So this is, like I said, is the conservative approach. We're making sure that we look at our worst case behavior. But what that means is that we're potentially foregoing some potential really good profits. Look at what our allocation strategy is. We're putting a bunch into this intermediate bond because it barely loses money when it loses money, right? So we don't get a really terrible behavior from it. But we have 0% here where we could get really high returns. And we have 0% here where we could get really high returns. So we're missing out on potentially really good behavior because of this conservative approach to our asset allocation strategy. Okay, and so the next thing that you can do is instead of having this min-max that we've done, we can have a fixed minimum that we can say, as an investor, as long as I make this minimum return, then I'm okay. And so your textbook says, well, let's investigate 2%. What if our minimum was 2% instead? So I'm going to make a new sheet. Oh, that didn't work what I wanted. There we go. I'm going to make a new sheet because we're gonna have to change our investment strategy around a little bit. Now, what we're going to look at is we're going to give it a fixed minimum here. So let's turn this off. We're going to give this a fixed minimum. Let's say 2% right here. And now we can't do these same sort of constraints anymore because now we don't know what the return is going to be, what the best allocation strategy is going to be. So what we're going to do instead is we're going to take our year, well, let's just delete these right now. And I'm going to go like this. let's make those all percentages. Okay, so let's start off by saying that we don't know what the likelihood of any given year is to happen. So we'll assign equal probability to each of these 5 years. It could be that our experts, our financial experts, change these probabilities, but for the sake of discussion for building this model, we'll just assume that each of these years are equally likely as each other. Okay? So now what we need to do is, given this probability, we need to figure out what our return would be for each one of these values right here. Okay? So let's go ahead and call this expected return. Okay, so for the foreign stock, all right, since each one of these are equally likely, what we can do is we can multiply this probability times this rate here. And we can do that for each one of these right here. And we will get what we would expect for any given year from that stock right there. So, again, we're going to use our sum product. We're going to multiply the returns for any given stock by the probability that that year is going to happen. And I'm going to do a little bit okay, because then I can cut and paste. Right? So if you're not familiar with Excel, what this dollar sign means is if I cut and paste, don't change these values, right? So when I cut and paste this equation here, I really want the 8th row. And so I put $8 through $8. So when I cut and paste this, I'm going to change B and F. I'm going to change 2 to 3 when I move from row 2 to row 3. So when we go down, you can see, it'll be a little easier if I click on there, right? It's a little easy. I didn't change the probabilities because I put the dollar signs in front of them, but I did change the stock that I was multiplying those probabilities by because of those dollar signs there. So I only had to type in this sum product once, and then I could cut and paste from then. All right? So, yes?
E7 is, E6 is 58.68.
This is 58.68? Thank you. Whoops. I think that's not going to change this one. We can try it real quick. Rerun our... Nope, because it stays at 0%. But thank you. That is going to make a difference here. Okay? So this is how much we expect if to make for our allocation strategy. So let's go here. Expected return overall. Let's just call it return. So our overall return is just going to be this allocation times the expected return here. So if we had this allocation strategy that I just copied from the previous one, we would expect to make 10 2/3% return on our investment right here. But let's see if we can make it a little bit higher. Okay, what are the constraints now? What is the constraint around year one? What do I need to be true?
You have to multiply each row by the probability.
No, because I'm looking specifically at year one. We already did each row by probability to get this expected return for each potential stock. So we're looking at what needs to be true about year one. The answer is that we need it to still stay above this minimum value right here. That's the constraint that we have. So our year one returns are the returns times our allocation that we already did right here. Notice that the difference between this and the previous sheet is I'm not subtracting off that minimum. Oops. Year 3. And we see what we already saw on the last thing, that our returns for years 3, 4, and 5 do end up being 6.44% right here. So let's see how our model changes now. Okay, let's start with our objective cell. What is our objective in this case? What do we want to maximize or minimize? We want to maximize our overall return. So we're going to take this overall return here and maximize it. What are the variables in this case? What can the model change? What are we asking for advice on? What to invest in. So our variables should be this allocation right here. Okay? We're having a hard fixed minimum. This came from some sort of conversation between the financial analyst and the client, and we discovered that this was their risk tolerance. They couldn't lose, they couldn't go worse than 2% on any given year. Okay? So that's why that is not a variable like it was in the last model. Okay, our constraints, again, are these returns right here. And what needs to be true about them? What needs to be true about each of these returns? Greater than or equal to what? To our minimum, okay? So it's greater than or equal to, I'll just put this cell in right there. All right. Do we have any other constraints? Yeah, we still need to make our allocation right here be 100%. Okay, so you can see right here, now we have all these tied to this minimum. We want to maximize this, and this is based on what we expect to get back from these returns and we're going to change these as much as we can. So we're going to try to have heavy allocations on these three because we can get some serious returns from them, but we can't go too far because we can get kind of penalized from them, right? And so this 2% is what's going to protect us from that year 5 disaster that shows up in this table right here. So let's go ahead and solve it. And you can see that if we're willing to tolerate a lower minimum of 2%, we can get some much higher returns. In year 4 now we can get 31% instead of that 6.4% that we got with that other allocation. This is 22% instead of, I forget what it was before, 6 plus 5, 11%. And this is 29% instead of 15 plus 6, or 2%. So we've improved in every year except these two. These 2 years we've gotten less return, right? We only got 2% in these 2 years. We only got that minimum return instead of the 6.44%. So if we have a more risky strategy, we can make higher returns if these are available. And now what you can do is you can play around with this model. You can change the probabilities and say, well, our experts really tell us that this is the more reasonable thing. This happens half the time. And the rest of these happen 10%, what's that, 80? There we go, we got 100% right there. Right? So you could run it with that, resolve it, and you get a different allocation out of it. Let's put that back to 20%. There we go. All right? Or you can say, oh, what if we have someone who's even more risk tolerant? Say maybe some of you who are thinking about graduation, you're starting to think about investing in retirement funds. You probably can afford losing a little bit of those retirement funds now in your early 20s if that's going to result in larger returns between now and when you retire. So what if you said, I could handle even losing as much as 5% in any given year? What would happen then, right? And so we can resolve our model. And you can see now, in these 3 years, we've got really high returns, 50%, 30%, 20%. And in 4 out of the 5 years, we get positive returns on our investment if we're willing to lose 5% that fifth year occasionally, right? And so this is a way that we can optimize this asset allocation directly based on the risk tolerance of the particular investor that we're talking with. And so all you have to do then is when you want to do this is you get some financial expert. Maybe you're an investment company, and so you've got people. That's what they do, is they figure out the probabilities of these things. You figure out these returns. You figure out what the probability is, and then you send the analyst into the field, and they talk and learn from the different investors what their risk tolerance is. All they have to do is plug in this one number, right? What is the minimum that they can possibly handle for losses? You put that in there, and then it computes, and it gives you an overall strategy, right? Which this kind of reflects what a lot of financial analysts might tell you. If you've got a long time horizon, those small cap funds are going to give you the biggest bang for your buck, and you can see why in this kind of an experiment right here. Okay? So I believe for Wednesday, your assignment is to do something very similar to this with a different data set. It has different number of years, different number of stocks, but it's the same basic strategy. Or was that today's assignment? Today's, okay. Sorry. Let's prep for Wednesday's assignment. All right. Let me save this. What's this? All right. There we go. So for Wednesday's assignment, we're going to look at what's called revenue management. And the idea behind revenue management is we're looking at what are called perishable resources. In other words, they don't last forever. And the example in your textbook that uses are airline tickets and hotel rooms. Okay, so we'll go through the example in your textbook that is airline, and then your assignment will be hotel room.
I
Yes.
think that assignment was due today as well.
That what?
Yeah.
Okay. You had 2 to do today?
Yeah.
Well, they were due like a year ago.
Oh, I'm sorry. If you look at, I'm sorry, I'm falling behind. Would it help if we talked about, or did you guys just figure it out on
You
your
can
own?
still talk about it.
We should talk about Wednesday's assignment, that's good.
Which is,
15.4 or 5.14.
that's a game theory one?
Yeah. There's a 5, a 1, and a 4.
5.13. How about this? How many were confused by the revenue management assignment today? Okay, I'd rather talk about that rather than just move on, and I'll make the game theory one due after fall break, and I'll let you resubmit the revenue management one for Wednesday, so that you can actually do something that makes sense rather than trying to guess what you're supposed to do. All right. So, if you open up your textbooks to section 5.2, it uses the airline example, and then your assignment will be hotel rooms. All right. So, can someone turn on the lights, please? I'm going to draw on the board a little bit. So what we have here is we have 2 starting locations for our airplanes. That's not visible. 2 starting locations for our airplanes. And like a central hub. Right? So what's one of the starting locations that we can start at? Section 5.2. Pittsburgh, okay. What's the other one?
Newark.
And what are the ending locations? Orlando. And M-R-Y? No, M-Y-R. And what is the hub then?
Charlotte.
Charlotte, okay. And so what we have we have 2 planes. So plane 1 can fly to, say, Pittsburgh to Charlotte, and then from Charlotte to Orlando, as an example. And plane 2 can fly from Newark to Charlotte, and then on to Myrtle Beach. Okay? But that doesn't mean the passengers have to stay with the planes, right? We can start at Pittsburgh and end at either of these 2 destinations by either staying on the green plane or switching to the blue plane here. And the same is true we can start at Newark and stay on the blue plane or switch to the green plane here, right? So we have 4 possible ticket combinations. Pittsburgh to Orlando, Pittsburgh to Myrtle Beach, Newark to Orlando, Newark to Myrtle Beach, and while we're at it, we can also have 2 additional ones to this main location as well, right? And so we know the size of our airplanes. We know how many the green airplane can hold. We know how many the blue airplane can hold. So we've got those size constraints that we can't avoid, right? Those are physical constraints that we can't get under. But then we also have pricing, right? We have first class, we have economy, and so of course we would like to sell as many first class plane tickets as we can, but that's not reasonable. We know that not everyone's going to buy those tickets. So what we're going to do is we're going to have some sort of forecast. We're going to say that we expect the demand from Pittsburgh to Orlando to be this much at the economy prices and this other amount at the first class prices. All right, and so we've got 2 different pricing structures. And so what we need to do is we need to decide, given those constraints, physical constraints about how many seats are in an airplane, and given our expected demand for each of these economy and first class tickets, how many seats should we reserve for each one of those classes on each one of these different segments in order to maximize our constraint, maximize our revenue. All right? Is everyone following me so far? For your assignment with the hotel rooms, it's the same kind of thing. Do you sell some hotel rooms for Friday only pricing, some for Saturday only pricing, and some for Friday and Saturday pricing? Right? So you've got multiple pricing structures, and how many people do you expect to only come on Friday? How many people do you only expect to come on Saturday? Versus how many are going to buy that joint ticket? All right. So what are the constraints that we have in this system right here? Okay, how many seats can we hold on this segment right here? What's the constraint there? $132. Now I just did green here, so I don't remember which plane goes where. What's the constraint here? 132. How about the blue ones? Are they also 132? So yeah, so we've got the same plane here, okay? So how do we make sure that that's true? Well, we have to look at what all the different flights are out, right? So what flights could take this path right here? We got Pittsburgh to Charlotte, we get Pittsburgh to Orlando, and we get Pittsburgh to Myrtle Beach, right? Those are the 3 ways that could travel that way. And then you have, for each one of those, you have your 2 classes, right? I think your book calls them Y and Q, right? So you get like PC, Y, PC, Q, POY, and POQ, and PMY, and PMQ. Okay. So if you take those tickets, these are variables that we're going to use in our model. We're going to let the model decide how many of each of these we will make available. And we just are going to make sure that when we sum them all together, they're less than or equal to the number of seats that are available on the plane. Okay? And we do the same thing for each one of these routes right here. We figure out what routes go on this, what routes go here, and what routes go here. Right. Yes?
Why would it be less than 132? Wouldn't you always want to fill all the seats?
You want to, but maybe if you can sell a higher passenger from from Charlotte and you need to reserve
Okay.
space
Right.
from them, or someone coming from Newark,
Okay.
and so you might not use all the seats
Save some for-
to save for a higher paying passenger later on.
Okay.
All right. And so we have those 4 constraints right here. Okay, so those are 4 constraints that we have to put in our model. The other constraints that we have to put in deal with our forecast. Okay, so these I would call capacity constraints. And then you have your forecast constraints. And so some other program probably running on some other computer told you that we expect that the number of seats that are going to be demanded for this trip from for first class from Pittsburgh to Charlotte is going to be what? What was that amount? What's the forecast amount from Pittsburgh to Charlotte first class? 16, okay? And there's going to be that same forecast for all the possible tickets that you could purchase, right? What you need to make sure is also true about your model is that each one of these forecast amounts right here limits how much tickets you spend. Because if you offer 17, 18, 19 tickets here, no one's going to buy them. So then you're putting an unused opening for no good reason, right? So this forecast is going to bind these different tickets that you make available. You make sure that you don't offer more than you expect to occur. All right? So then you can then have these 2 constraint types. Your capacity constraints and your forecast constraints. And then your objective is just going to be multiplying each of these ticket types times the revenue that they bring in. So if you sell Pittsburgh to Charlotte first class, you make this much revenue. Versus if you do economy, you make this much revenue. And that's what you try to maximize, is that amount, is that revenue. Okay. So then the interesting thing comes, and we will look at this on Wednesday, is what do you do when you've sold all the tickets that you've made and someone says, hey, can I buy another ticket? And you look and your capacity constraint is not filled. How much should you charge that person to fill that empty seat? Okay, and that's where our sensitivity analysis comes into play. All right, because how much additional can we increase our objective by increasing this number right here because we had sold them all out. All right, I'll see you guys on Wednesday, and I'll refigure when things are due to reflect our discussion today.